When dealing with an old switchboard, safety is paramount. Before undertaking any testing or load calculations, ensure all proper safety precautions are in place. This includes wearing appropriate personal protective equipment such as arc-rated clothing, safety glasses, and insulated gloves. For testing the main breaker, firstly, perform a thorough visual inspection of the main breaker. Look for any signs of visible damage, corrosion, or loose connections. Secondly, conduct a resistance test on the breaker's trip coil. This test verifies that the coil's resistance is within the manufacturer's specified range. A reading outside this range could indicate a faulty trip coil. Thirdly, perform a trip test. It is crucial that this test is only performed by a qualified electrician. Use a calibrated trip tester to apply a load to the breaker and simulate a fault condition. Verify that the breaker trips within the time current curve specified by the manufacturer. This confirms the breaker's ability to respond correctly under fault conditions. Fourthly, lubricate the breaker's operating mechanism according to the manufacturer's instructions. This ensures smooth operation and prevents sticking. Fifthly, exercise the breaker several times to ensure smooth operation after lubrication. For performing a load calculation to determine if the switchboard is overloaded, firstly, gather equipment data. Collect information on all electrical devices connected to the switchboard. This includes their voltage, current, and power factor ratings. This information is typically found on the equipment's nameplate. Secondly, calculate the connected load. Sum the power ratings of all connected devices to determine the total connected load. The load can be expressed in kilovolt amperes or kilowatts. Thirdly, apply a demand factor. Multiply the connected load by an appropriate demand factor. The demand factor accounts for simultaneous operation, diversity, and usage patterns. Demand factors are typically based on historical data or industry standards. Fourthly, check against the panel rating. Compare the calculated load to the switchboard's rated capacity to determine if it is overloaded. The switchboard's rated capacity is usually found on its nameplate. Fifthly, consider future expansion. Factor in any potential future additions to the electrical system when performing the load calculation. This helps to ensure that the switchboard has adequate capacity for future needs. If the load calculation indicates an overload, or if there are concerns about the switchboard's safety, it is recommended to consult with a qualified electrical contractor or engineer. They can perform a more detailed analysis and recommend appropriate solutions. Remember, when dealing with electrical equipment, always prioritize safety and seek professional assistance when needed. Now let's elaborate on each of these steps in more detail, providing further technical insights. Visual inspection of the main breaker. A meticulous visual inspection can reveal a lot about the breaker's condition. Look for these specific issues. Check for any signs of overheating, such as discoloration or melted components. Overheating can indicate loose connections or excessive current flow. Inspect for any signs of corrosion, especially in humid or corrosive environments. Corrosion can degrade the breaker's performance and compromise its safety. Look for any signs of physical damage, such as cracks, dents, or broken parts. Physical damage can impair the breaker's functionality and structural integrity. Ensure all connections are tight and secure. Loose connections can cause overheating and arcing. Resistance test on the trip coil. The trip coil is responsible for initiating the breaker's tripping mechanism. A resistance test can help identify potential issues with the coil. To perform the test, use a multimeter set to measure ohms. Disconnect the breaker from the power source before performing any electrical tests. Connect the multimeter leads to the trip coil terminals. Record the resistance reading and compare it to the manufacturer's specifications. A reading that is significantly higher or lower than the specified range may indicate a faulty trip coil. Trip test with a calibrated trip tester. A trip tester is a specialized device that applies a controlled current to the breaker's trip coil, simulating a fault condition. The trip tester allows you to verify that the breaker trips within the specified time current curve. To perform the test, connect the trip tester to the breaker's trip coil. Set the trip tester to simulate a fault current that is within the breaker's rating. Activate the trip tester and observe the breaker's tripping time. Compare the tripping time to the manufacturer's time current curve. The time current curve specifies the acceptable tripping time for various fault current levels. If the breaker does not trip within the specified time, it may indicate a malfunction. Lubrication and exercise of the breaker's operating mechanism. Lubrication and exercise are essential for maintaining the breaker's smooth operation and preventing sticking. Use a lubricant that is specifically designed for electrical equipment. Apply the lubricant to the breaker's moving parts, such as the operating handle, linkages, and pivots. Exercise the breaker by repeatedly opening and closing it several times. This helps to distribute the lubricant and ensure smooth operation. Gathering equipment data for load calculation. Accurate load calculation requires gathering detailed information on all electrical devices connected to the switchboard. Collect the following information for each device. Voltage rating. The voltage rating is the voltage at which the device is designed to operate. Current rating. The current rating is the maximum current that the device can draw. Power factor. The power factor is the ratio of real power to apparent power. Real power is the power that is actually used by the device, while apparent power is the total power supplied to the device. The power factor is typically expressed as a decimal value between 0 and 1. Nameplate information. The voltage, current, and power factor ratings are typically found on the device's nameplate. Calculating the connected load. The connected load is the total power rating of all electrical devices connected to the switchboard. To calculate the connected load, sum the power ratings of all devices. The power rating of each device can be calculated using the following formula: power equals voltage times current times power factor. If the power rating is given in watts, divide by 1000 to convert to kilowatts. If the power rating is given in volt amperes, divide by 1000 to convert to kilovolt amperes. Applying a demand factor. The demand factor accounts for the fact that not all electrical devices will be operating at their full rated power simultaneously. The demand factor is a multiplier that is applied to the connected load to estimate the actual load on the switchboard. The demand factor is typically based on historical data or industry standards. The National Electrical Code, NEC, provides guidance on demand factors for various types of loads. For example, NEC Table 220.42 provides demand factors for general lighting loads and various types of occupancies. To apply a demand factor, multiply the connected load by the appropriate demand factor. Checking against the panel rating. The switchboard's rated capacity is the maximum load that it can safely handle. The switchboard's rated capacity is typically found on its nameplate. Compare the calculated load to the switchboard's rated capacity. If the calculated load exceeds the switchboard's rated capacity, the switchboard is overloaded. An overloaded switchboard can overheat and potentially cause a fire. Considering future expansion when performing a load calculation, it is important to consider any potential future additions to the electrical system. This helps to ensure that the switchboard has adequate capacity for future needs. To account for future expansion, add an estimated load for any planned additions to the calculated load. Seeking professional assistance if the load calculation indicates an overload, or if there are concerns about the switchboard's safety, it is recommended to consult with a qualified electrical contractor or engineer. They can perform a more detailed analysis and recommend appropriate solutions. An electrical contractor or engineer can perform a load study to determine the actual load on the switchboard. A load study involves measuring the current flow on each circuit in the switchboard over a period of time. This data can be used to calculate the actual load on the switchboard and identify any potential overloads. Based on the load study, the electrical contractor or engineer can recommend appropriate solutions to address any overloads. These solutions may include adding a new switchboard, upgrading the existing switchboard, or reducing the load on the switchboard. Safety considerations when working with electrical equipment. Always prioritize safety. Wear appropriate personal protective equipment, such as arc-rated clothing, safety glasses, and insulated gloves. Disconnect the power supply before performing any electrical work. Use properly insulated tools. Never work on live electrical circuits. If you are not qualified to perform electrical work, consult with a qualified electrician.